Bismillahirrahmanirrahim. Assalamualaikum. This is Masajid and along with Voya I am going to discuss the application of different types of titration method analysis. So the types of titration used are the acid-base titration and redox titration. The first is the chlorination of public water supplies. Chlorination is a process in which the wastewater is treated on to make it useful for drinking and other purposes. These are the basic steps of the chlorination. In the first step, the water is taken from the source. In the second step is screening, in which the water is passed through the screen in order to remove the large items. In the third step, flocks are made by treating the water with a chemical, which converts the smaller particles into the larger particles, which are flocks. In the fourth step, the flocks are settled down and the water is filtered. In the fifth step, the water is disinfected by using the chlorine, which kills the bacteria and the other infectants. In the sixth step, the pH of water is adjusted and the chloride ions are added in the water. In the seventh step, the water is supplied to the homes. These are some of the terms which are used in the chlorination. The first is the chlorine end, which is the amount of initial chlorine concentration which is added to the water. The chlorine demand is the concentration of chlorine which takes to the organic and inorganic materials which are present in the water. The total chlorine concentration is the amount of chlorine which is remained after the chlorine demand of water is met. In the total chlorine concentration, there are two concentrations: free chlorine concentration and the combined chlorine concentration. Free chlorine concentration is the concentration of chlorine which is freely available for the disinfection, and the combined chlorine concentration is the concentration of chlorine which is combined with organic or inorganic compounds in the water. So the first application is the determination of total, free and combined chlorine. These are all determined by the redox titration. The first one is the determination of total chlorine concentration. We use the water sample in which chlorine is present and we add small amount of potassium iodide crystals in it, and we use this as a titrant. And the titrant is sodium thiosulfate solution. The indicator is the start solution. These are the basic steps of the procedure. In the first step, we take the small amount of water sample and we add acetic acid in it. Then in this second step, we add small amount of potassium iodide crystals in this water sample. The chloride ion is present in the water sample oxidizes the iodide ion into isomer ion, which turns the solution into the brown color. Next is brown color solution is titrated with the sodium thiosulfate solution until it turns into the yellow color. Then we add a small amount of starch as an indicator. This converts the solution into blue color of starch iodine complex. And then this blue color solution is again titrated with the sodium thiosulfate solution, which is converted into colorless solution, which is the end point of the titration. So this is an indirect titration method because the concentration of chlorine is not determined directly. But first we determine the concentration of ice in negative ion by adjusting with the thiosulfate solution, and this concentration is induced indirectly process to determine the concentration of chlorine in the sample. The next is the determination of free chlorine concentration. The titrant is ferrous ammonium sulfate solution. This is a green color solution. Titrant is chlorinated water in which free chlorine is present, and the indicator is DPD, which is diethyl phenylene diamine. These are the basic steps of the procedure. In the first step, the chlorine oxidizes the DPD, which is indicated into the red color DPD. The solution is red in color. In the second step, the red color solution of water sample is titrated with the ferrous ammonium sulfate solution, and in the third step, the red color solution of water sample is turned to colorless solution, which is the end point. And the volume of titrant, which is a ferrous ammonium sulfate solution, is used to determine the amount of free chlorine in the water. Next is the determination of combined chlorine concentration. All the materials are same which are used in the renovation free flooring except the analyte. In the free flooring consideration, the analyte is a free flooring, but in the combined determination combined flooring consideration, the analyte is monochloramine. And the titrant is being chlorinated water with a small amount of potassium iodide. Potassium iodide is used to reduce the monochloramine in order to oxidize the DPD as in the previous case. The procedure is same as in the determination of free chlorine concentration. First, we titrate the water sample which contained oxidized DPD and the monochloramine with the ferrous ammonium sulfate solution. And the volume of ferrous ammonium sulfate solution is used in the titration is used to determine the amount of monochloramine in the sample. Similarly, the amount of dichloramine and trichloramine is also determined through the same procedure. The second application is the determination of total and free alkalinity of the cleaning bath. The cleaning bath is used in the car industry, and it is generally a mixture of strong base with other salts like silicate and phosphorus. The alkalinity of the cleaning bath is due to the three components: carbonate, bicarbonate, and hydroxide. The total alkalinity is the sum of all these three forms, and the free alkalinity is the measure of the hydroxide and half of the carbonate. And so the total in free alkalinity is determined by the acid-base titration, in which we use sulfuric acid as a titrant. The titrant is a sample of the cleaning bath, and through the acid-base titration we measure the alkalinity of the cleaning bath. That's all from my side. Now Huria will proceed.
Bismillahirrahmanirrahim. I am Huria Absaf from Chemistry Department, and I am going to discuss about COD, which is abbreviated form of chemical oxygen demand. So what is basically COD and how we determine it? So COD has many definition, but we keep it simple now. It is simply defined as the amount of oxygen which is needed in order to carry out the chemical breakdown, or we can say that the chemical oxidation of organic matter, or it is an indicative measure of the amount of oxygen that can be consumed by reaction in the measured solution. So now we move forward towards the other slide. So the question arises here: how we can measure it, and how we measure it, and why we measure it. First I give you the answer of why we measure it, and there is a quite number of reason behind it. The first reason is that it gives us the water quality check of our water reservoirs and tell us how much they are polluted. And secondly, it is also give us the information about the water treatment product. Now if we move toward the question how we measure it, so we use different types of titrations to measure COD, mostly redox titration, in which we use strong oxidants like potassium chromate, and the quantity of oxidation used is given in the amount of is given as the amount of oxygen present in a reservoir. And the titration of COD is carried out in acidic medium, and it is expressed in milligram per liter, which means the mass of oxygen consumed per liter of the solution. Now we take a look to another slide, which is in which different reagents are shown, which we use in the determination of COD redox titration, in which the first reagent is a potassium dichromate, which is a strong oxidizing reagent, and the second one is concentrated sulfuric acid, which we use to acidify our titration mixture, and the third one is the ferrous ammonium sulfate, which it is used in the back titration in order to determine the concentration of an excess dichromate ions in our solution. And this is ferroin indicator, which is used to detect the endpoints. And this is a silver sulfate, which act as a catalyst, and this is mercurial sulfate crystals, which avoid the chloride impurities which can affect which can react with the silver and allow the silver to precipitate as a silver chloride. In order to prevent it, we use mercurial silver crystal, and this is organic free distilled water, and this is all the reagent which we use in order to determine the COD. Now the determination process of the determination process of the to the for the measurement of the COD. So firstly we use a reflex mix sample or sample of the sample in which we use dichromate, and sample is acidified with sulfuric acid and silver sulfate, which is act as a catalyst, and we use mercury sulfate as I told earlier that we added it to complex any chloride, preventing the precipitation of our silver catalyst as a silver chloride. And in this titration, efficiency of oxidizing organic matter is 95 to 100%. And after and we do back titrations as well. In this titration, back titration, we perform the determination of excess dichromate ion by using ferrous ammonium sulfate as a titrant, and we use ferroin as an indicator in this titration, in this redox titration. So this is the pictorial demonstration of the process. This is these test tubes contain the samples which is made up of potassium dichromate and sulfuric acid, and we put this test tubes in the separators to heat our sample to 180 degrees Celsius up to 1 hour. And this is the strength in which we insert our test tube, and then we put them in this apparatus. Now the next topic is dissolved oxygen. Dissolved oxygen determination by the Winkler's method. So this is a technique, basically this is the technique which is used to measure the dissolved oxygen in the fresh water system, and in this test performance is performed on site, as because the delay between the sample collection and testing may result in the alterations in the oxygen content, which may affect our results. So what is dissolved oxygen? We basically dissolve oxygen in our water reservoir tell us about the health or cleanliness of the lake or a stream, and higher dissolved oxygen concentrations show us the correlated with high productivity and litter pollutions of the reservoirs, and the amount and the type of biomass which freshwater system can support, and the amount of decomposition occurring in the lake or a stream. And the dissolved oxygen is measured as milligram of oxygen per liter of the water, which is mg per liter. So it's a pictorial demonstration of the process. It's a BOD bottle with the sample. We add 1 milliliter of magnesium sulfate reagent in it, and add 1 ml of alkyl iodide azides, and replaced stopper and shake to mix. Then we add 1 ml of sulfuric acid and replace stopper and shake to mix, and then titrated it with a 201 milliliter of sample in aluminum flask, which and add 1 ml of starch indicator, which is a blue color. So when we add 1 ml of starch indicator, the sample color turn into blue, and then titrate sample until it clears. But I tell you once again that first we collect the sample, secondly we testing for dissolved oxygen. Firstly, we remove the stopper and add 1 ml of magnesium sulfate in the water sample. Then add 3 ml of alkaline potassium iodide into the sample and insert the stopper and shake vigorously. If oxygen is present, a brownish orange precipitate will form, and which allow the sample to stand until the precipitate settle halfway. Now remove the stopper and slowly add 2 ml sulfuric acid. Insert the stopper and shake vigorously to dissolve the precipitate. Now shake and wait until all the precipitate is dissolved and the yellow color is formed. Color is from iodine, and take 200 ml in a flask and titrate with the sodium thiosulfate solution in the presence of starch indicator. Now continue adding drops and mix until the prepared sample turn from blue to colorless at the end point. Now the result analysis, which is the total number of so we analyze that the total number of millimeter of titrant used in this process equal to the total dissolved oxygen in the sample, and the 1 milliliter of sodium thiosulfate is equal to 1 mg of solution oxygen dissolved. So that's all from my side. Thank you.